bottom line is what you should have come away with from yesterday's discussion is to find the volume of a thing that's being, to find the volume of a curve that's being rotated around a thing. It's just the integral from a to b of pi times the function squared, okay? And I know that we had a half an hour discussion about, why is it the function squared and all that kind of stuff. And if you followed along with that and if you understood that, then bully for you. But this is the main thing that you need to have in your notes to understand, okay? Right, it's a circle thing, okay? So it's pi times the function squared.
What does the B stand for?
What's that? Volume. That's how you find the volume, okay? So that's our volume. That is a pretty good job. This is a pretty good job.
Yeah, I mean, you got it quick.
Yeah, got it quick, got it right away.
Does it for circles alright?
No, because we did that with this curve here.
Has a curve, right?
Right, yeah. Okay, so we did that with this function right here where it was the square root.
So it would work with like.
So let's do another example, shall we?
Wait, let me write.
Okay,
Yeah.
thanks, Will.
Around the y-axis? Oh boy.
Oh, are we already going around the y-axis? Okay, that's fine.
What? Is it the exact same thing?
Yep, same.
No, I'm not.
No, it's fine. Okay, you ready?
No.
Hold on.
No.
Hold on.
Can you draw it for us?
Yeah, people are telling you to
Can
hold
just
on,
give me
so
a
I'm
hint
not.
what the first step is?
The first step is to draw the graph.
Oh, okay, actually, can you give me a list of steps so I know the
Okay,
steps? Not
first step
yet.
is to draw the graph.
I'm just asking for, he doesn't have that.
So there's the graph roughly of y equals x cubed.
And then it's just going to
Yeah, and we're spinning it around the y-axis this time.
That'd be like a cool design, like.
So yeah, so it's like the bolt, right? So it's going this way.
An hourglass, actually.
Okay. Well, but we're okay. You're right. As the bottom. Good call. Okay. So we've got
We're going
this.
from.
Right. But technically, what she's saying is, if we rotate the whole thing, we're going to get an hourglass. But what Evan says is correct. Also, that they want us to only find the volume from 0 to 8. So it's really going to be just like a bolt.
Should I use
Okay.
But it's X equals Y equals
Yeah, that's what
Oh, okay, well that's
So
just,
would it just be-
when x equals 0, y is also 0, right? Because it's right here in the middle.
I know, but how do we know they want it above the y-axis? If x equals 0, it could also be below the y-axis.
No.
Yeah, because you'll be going this way.
Right?
And then x equals 0 is that point, so why wouldn't it just be this half of it?
It's this stuff
It
above.
is.
It's from x equals 0, which is right here, to y equals 8, which is right
And we
here.
don't, okay, I'm confused about the line from the bottom part.
We don't care about that.
Like,
Because
for the
it's
rest
just-
of our lives, we would not care about that part.
No, because they could have said from -8 to 8, and then we wouldn't care about the bottom part.
So if they give us a negative y, then we care about the
That's
bottom.
That's why the first step is to make the graph. Okay? Okay, so then the second step, Mary, is to use the graph to figure out where you're going from. And in this case, we're going to go from 0 to 8.
So, what
But I'm still confused why it's x.
I don't know why they chose to do x equals 0, and we might as well just make that y equals 0 and then not worry about it. Okay, they would just be embarrassed about it. It's math people like that. So we're going to see if you really understand.
figure out
Why
the
the
region?
concepts?
Just deal with that. It's probably a typo on accident.
Could be. Anyway, so we're going from 0 to 8.
Long day.
Okay? All right, now we're going to take this and we're going to rotate it around. So we're going to use that formula I just gave you, pi times f of x squared. And I'm going to put the pi on the outside.
So forever.
Right, so forever we'll do that,
So
okay?
what do you-
And then we have to figure out what is the radius of a circle that we're rotating around.
It's
And
changing.
that, right, it's
That's the
changing.
thing we did
And-
yesterday.
Right, that's the thing we did yesterday. And so the radius is going to be defined by this function right here.
It's the thing we got really
Square
angry
root
about.
of r squared.
No,
No.
because this is not a circle, it's this.
But it is a circle though.
The cross sections are circles, right, but the curve that we're rotating
Oh,
around
it's
Root of
is
y.
y equals x cubed. But since we're going this way, we need to
Y.
rewrite it as x equals y to the 1/3. Because it's an x equals, not a y equals, because we're going sideways.
Why is it?
because I solved this for x, so I took the cube root of
Oh,
all.
because you want the x equals 0.
Right. Okay, so that's our function, so it's going to be y to the 1/3 squared, technically dy. Jefferson's probably being a rebel back there, just writing x's in there, because that's how it is, but yeah.
So what is step 4?
That makes me mad.
Solve the,
Okay.
What was that?
right the,
When he just switches the variables. So makes me mad.
we could do t and w, right?
No. Okay, and step 4 is the
Solve the-
derivative.
Yeah.
Well, why is it?
Yeah, I'm right, that's the, yeah.
Because the formula is pi times the
Writing
function.
step down.
I did not write that down.
Oh,
This other way
that's
makes sense.
important.
Wait, will you write the little board?
Will I what?
Write the steps over and write the
Uh-huh.
No, no, I didn't.
It wasn't meant.
Oh. That makes sense now, okay.
Fans.
Soccer at Elma.
We got a lot of quality athletes on the
I wrote it so much.
So it
better
says
than I did.
F of, oh, okay, okay, got it.
It's funny how like integration is also used for Taylor's roots.
Yeah.
Right.
It is,
For race relations.
yeah. We just have a French club.
Okay, so how are we going to solve this?
We're gonna use our calculator.
We're going to use our calculator. So
We
use
don't
your
want to
calculator.
Now-
use U.
Can you put the pi in front of one
You wouldn't even
calculator?
have to use a substitute.
You could, if you wanted to do this by hand, you would say pi 0 to 8. What's y to the 1/3 squared?
2/3.
Y to the 2/3, because when you have a power to a power, you multiply the exponent. And then, Mary, the antiderivative of y to the 2/3, you just use the power rule, so you add 1 to that, which would be 5/3.
No, I didn't
So it'd be
enter.
pi times y to the 5/3 over 5/3, right? Remember? Which then we flip that over, and that would be 3 pi over 5 times y to the 5/3, and then we want to plug in 8 and 0. If you plug in 8, you get 2, and 2 to the 5th is 32.
Yeah, you know.
So it is going to be 96 pi over 5.
I'm not worried about, okay.
Yeah, I would be worried about that too. Sorry, that's not very
No, just start
to
over.
say, but I'm like trying to emphasize it. Mary?
Okay, so the antiderivative
He's
works
laughing at me.
for, like what we've been doing with integrals works for the curve, and now we've added the extra dimension.
Yeah.
That's why it's-
Right, now that it's the thing squared instead of just the thing, that's why it's
Yeah.
right.
Did I bring my
What's,
calculator
Then you have to
yesterday?
multiply by
Hey.
pi.
I put a pi out.
Evan, what's 96 pi divided by 5? Right, okay. So the only problem, hey, the only problem that you guys have, well, there's two problems. One is when using the calculator, if you're thinking about a college math class or an AP test, there are sections where you can't use the calculator. So that's a problem. The other thing is what you have come up with is an estimate, where this is the exact
If you just
answer.
multiply on the outside and then multiply your final answer by pi.
You can divide your answer by pi, and then that would know what this is. 96 out of it, okay?
Should we try this one by
Sure. Okay, so let's do the region enclosed by y equals x and y equals x squared, and we're going to rotate it around the x-axis. So let's, oh no, because this is, there's something different that's going on here. Okay? No, but I have to teach it to you. So first step is still the same. Okay. What less visible?
The R looks cool, but no, it's problem.
Is it 2?
So, what? Okay, I'll fix it later. So we want to find the region enclosed by the curves y equals x and y equals x squared. So here's y equals x, right?
Yeah.
and then here's y equals x squared, and that's gonna dip
And they're
below.
both rotating.
What?
And so they cross right here
That's right.
at 1, 1. What happened? Or is that mine?
Yeah, and
Yeah.
So I'm gonna say.
You have so
So-
many texts now that you have an iPhone.
What?
You have so many texts now that you have an
They just do it now. I had them before, but like my
They changed it to
phone shut
5,
down
right?
or whatever.
So it's gonna rotate like this?
No, you're still going around
But it's
the
that banana.
x-axis, right? So do you recognize that something weird is going to happen now?
There's a space.
Because yeah, there's a space.
No,
Okay.
what
So we have to find the area
It's
under
gonna
the
look like a
curve
mustache.
also?
No,
It's gonna be a mustache.
We have to find the
You
area.
just have to find the banana.
but you're rotating the banana around, so it's a bowl. It's not a cone now, it's a
Oh, so
bowl.
there's gonna be a hole.
Okay, right, there's a
Wait,
hole
will you
in the
color
middle.
in them?
Okay, so I'm going to take this and I'm going to rotate it around, and so it's going to look like this,
Should we be writing this down?
run around, but then the middle is missing.
Ah,
Okay.
Oh.
So you see where it looks like a mustache, though, if you just subtract
Yeah,
it.
I see. For sure. Okay, so let's use the graph to set up the integral. So we're going to go from what to what?
What, no, wait.
We're gonna go from 0 to 1.
0 to 1. 0 to 0. 0 to 1. Okay. Pi. Anybody got it?
Is it, which one we want to cross first, right?
So y equals x on top.
Minus x squared.
Minus x
So we
squared.
get it all together, this is horrible.
And that is the radius of the shape. Nice.
Okay, but how many?
Two stupidest people in the class.
What's that?
How do you take out the middle? That's
We
not
did, when we were
nice.
subtracting. So if I were to just
Yeah,
do
you
this
didn't
as,
include Trish.
if I were to just do this as, this thing squared, then that would give me the whole thing. But then since I'm subtracting this x squared, then that
Oh, so
carves
it just
out
works
the
together.
stuff. Yeah, so, I'm sorry, so it's like this. You have to do the x
Squared
squared
minus x
minus
x squared squared.
x squared squared. So Evan and Taylor are still there. But they're not, you're not squaring both of them. This is the, this would give you the volume of the entire thing, and then minus the volume of the
So it's
inside.
not like the other.
Right, so you're gonna square first and then subtract, basically, okay? All right, so then if we do this, this squared is obviously x squared. This squared is x to the fourth. And then antiderivative of that, either on a calculator or by hand. If you do it by hand, it would be x cubed over 3 minus x to the fifth over 5. 0 to 1, so that would be pi over 3 minus pi over 5, which would be 2 pi over 50. Okay?
I love that it's in-
What?
I love that it's in-
Good. Everyone is a winner.
No, that's not.
All right, so from here, that is not true either.
It's like, it's inside.
Yeah, from here, things get more complex
Oh, yeah.
because we're going to start rotating it not over the x-axis,
But
but
around
around
a
the
different
y.
line.
Can we just
Yeah.
stop right now?
So we're going to just work on some of these problems for a little bit to practice what we hope to learn.
Do you mind if I go work on a project?
Is it a project for Mr. Holland?
Yeah.
No, that's fine. Let me give you your
You
assignment.
said no, and then you said that's fine. Jackie's so cute. I really gotta get a good grade.
Hey, don't.
I really need to report it.
You can't further those rumors. When something's gonna happen and then.
Everybody knows April's gonna get the medal in that class.
Is that what it's all about? That's the only thing that matters?
Yeah.
Only thing that matters is winning.
Actually,